Listo, pelado. ¿Ya puso a grabar? Sí.
Ya.
Sí.
Bueno,
It's
listo. Entonces,
recording.
hello, everyone. We are gonna presentate with my group this paper denominated a framework, a toolkit for testing the correctness of recommendation algorithms. Next. In this part, we have a context and motivation. Rigorous evaluation of recommender systems is vital. Traditional offline evaluation often relies on metrics like NDCG or recall, comparing algorithm performance on held out data. However, this overlooks software correctness testing, a standard practice in software engineering. This work adapts testing concepts, code coverage, metamorphotic testing, property-based testing for recommendation algorithms. In this part, we have the problem with the traditional evaluation. We have a table. This report significant difference scores and rankings for the same algorithms. For example, algorithms ACE, SLIM, IELTS of new FM. These scores in EASE is 0.336 versus 0.449. In the new is 0.270 versus 0.470. Despite a small difference in data splits, reproducibility issues. Studies shows inconsistent algorithms published years ago. Sometimes outperform never owns, and even independent studies disagree on rank. Continuing, the implicit misplaced trust. Offline evaluation assumes algorithms implements are correct and robust, which is not guaranteed. Sensitivity and lack of robustness. Small changes in offline experiment setup, datasets, splits, metrics can lead to vastly different performance, ranking among algorithms, hindering comparison and real progress. Oracle program in machine learning. Defining the expected correct behavior, the oracle for a given input, especially difficult in ML and recommendation systems, as there's often no single right answer or the answer is unknown. Need for complementary evaluation based solely on aggregate metrics ignore important aspects like robustness, reproducibility, on the shared basis and implementation errors.
Okay. Let's begin with the proposed solutions. This framework is designed to ensure correctness in recommendation systems by combining both black box and white box tests. These tests operate at three levels: unit, integration, and system. The framework focuses specifically on collaborative filtering algorithms that work with implicit feedback, especially for top K and sequential recommendation tasks. Okay, here you can see a detailed overview of the test suite. Each row corresponds to a specific test with a unique ID, a description of the objective, and the type of task it applies to. For example, sequential or top K recommendation. Also, consider the kind of item, representation, and the learning method used. Okay, continuing. To the test suite includes a variety of test types. BBST and BBIT are black box tests, focused on system level and integration level behavior. And WBST and WBIT WBUT are white box tests that look into internal model logic, such as embedding or gradient updates. There, together. Sorry. These tests from a comprehensive framework to access the correct and robustness of recommendation systems.
That's all. Okay, for the next topic, I will talk about expression validation. That it means the main objective of this experimental evaluation is to validate the correctness of the recommendation algorithms, adapt software testing principles such as unit, integration, and systems tests, and also detect functional errors, reproducibility issues, and undesired behaviors. This object, this objective was applied to four libraries: Repack, PyLensKit, Surprise, and Cornac using both black box and white box text cases. And uh, as you can see, this table show us how test totales, total test and exit test and falling test. This is all the results, and the next this says the test revealed actual bugs and design issues within the package. The speed then been well known and actively maintained libraries. It was observed that several models lack reproductively, failing to produce consistent results even when using the same random seed. And moreover, some complex algorithms were unable to learn simple patterns. The repack test framework proved to be a valuable tool for computational evaluation methods by providing systematic verification of functional correctness. It is proposed to extend the test suite to cover additional tasks such as sequential recommendation or those involving different domains. Um, for the next topic, validate findings and statistics. Um, for the first, and the objective is an automatic test suite was developed to evaluate the correctness of recommendation algorithms, especially those based on implicit feedback. Uh, Here we test the libraries I talked recently. No, for the results we can see the table, the element table. That means there's like BBS-T2 and BBE-T5 achieved as 100% rate. In the country, there is certain algorithms will highly consist in a specific tasks. Others, such as a BB81 top K, 48%, and BB81 sec, 25%, showed low success rates, revealing difficulties in learning simple patterns on the sequence from the data. But what it means, the table 11 shows how reliable and accurate the algorithms are under different types of tests, the simplest and most traditional ones. Prove it, prove it to be the most robust. In contrast, complex models such as Mod BA or new MF fail more frequently, especially when not properly configured. And that's all for key findings and studies.
Okay. Finally, I want to highlight key points about our work with correctness testing. First, correctness testing does not replace but rather complements traditional performance evaluation. It allows to detect internal errors that might otherwise go unnoticed in a superficial evaluation. Second, with repack tests, we were able to identify specific problems in widely used common recommendation libraries, reinforcing their practical utility and potential for improving the quality of existing system. And finally, looking ahead, we plan to expand the number and diversity of tests, cover more algorithms and properties such as robustness and fairness, and explore formal guarantees to validate the complements or results. Next. This table compares Repack test current capabilities with the goals set for future work. The first column lists the aspects evaluated, such as the type of test, the libraries covered, and the properties analysis. The second column shows the current state of the system. For example, specific tests have been performed on popular libraries, but still with limited coverage. The third column summarizes the planned improvements. We seek to include more test classes, different tests, expand the number of algorithms, and evaluate more complex properties such as robustness and fairness. We also want to incorporate formal guarantees that allow us to evaluate the complements of the system. ¿Listo? ¿Quieres
That's
grabar?
all.
Perfecto.